we're starting a new packet today since we took the test last class. I only have one class of the packet for you. I sent it down to be copied. Too late to get it in time for class today. So I just printed the first lesson for you, and next class you'll have a whole packet 3. And that packet has this other stuff that you were curious about, these grids and stuff. But you don't need those for today. All right, so class 21, we're going to talk about percentages and simple interest. So we have done some work with increasing and decreasing by a percentage when we talked about exponential growth. So we're just going to formalize that a little bit today, and then we're going to talk about simple interest. So the deal with percentages is that since many people don't like dealing with fractions, and because fractions with different denominators are hard to compare, like which is bigger, 2/7 or 5/8, right? Well, that one's easy, but when you have different denominators, it's hard to compare the sizes, right? If you ate, you know, a half of a pizza versus, that one's going to be easy too. Let's say 3/8 and 2/7. 3/8 or 2/7 of a pizza. That one's a little hard to compare, right? So we have developed a common standard denominator. So this is just so that when you want to compare fractions, we just take any fraction and we make it the denominator 100. So that's what a percent is. It's a fraction with a denominator of 100. It can be interpreted as a percentage using the percent symbol, and that indicates the presence of a hidden denominator of 100. So X% means X over 100. Okay, so percentages provide a nice way of making comparisons. They provide a useful way of dealing with fees, taxes, and tips, and they help us better understand how things increase or decrease relative to some baseline. Okay. So, for example, suppose that in your English literature class you scored a 19 out of 25 on a quiz, a 49.2 out of 60 on the midterm, and 124.8 out of 150 on the final exam. Which one was your best test score? How'd you figure that out?
I didn't figure it out by how approach it by 25 by 19. Or another way, I'm sorry.
Yeah, divide 19 by 25, and that will give you a decimal that we can then change to a percent. Yep. So I'm going to take each of my scores and divide, because a fraction bar, it means division. Fractions are division, right? So if I write 19 out of 25, 49.2 out of 60, and 124.8 out of 150. Those are 3 fractions, and I want to know which fraction is the biggest. So a useful way to compare fractions is to use a decimal or a percent. And to create the decimal, you divide. Fraction bar just means divide. So that says 19 divided by 25, and that's 0.76, which is 76%, right? 0.76 means 76 hundredths, because there's 7/10 and 6 hundredths is 76 hundredths, and 76 over 100 means 76%. So you can quickly go from the decimal to the percent by moving the decimal point 2 to the right. All right, so 49.2 out of 60 is 0.82. And as a percent, 0.82 is 82%. And then 124.8 over 150 as a decimal is 0.832, which converts to 83.2% with the decimal 2 to the right. All right, so which is your best score? The last one, the 124.8 out of 150 on the final exam. Convert them all to percentages just to make them easy to compare. All right, think about this. Is 3/20ths a reasonable restaurant tip? I know it's a weird way to say it because that's the whole point of percentages, is that they give us a common frame of reference. So I'm writing this in a weird way, 3/20ths, change it to a percent and see if that's reasonable. Okay, so 3/20ths, that is a weird way for me to express how much to tip, right? So 3/20ths is a very strange way to say that, because we generally talk about tipping in terms of a percentage, right? So what is 3/20ths as a percent? 15%. So there's two ways to get there that I saw people doing. The first way is the way that I showed you in the first example, 3 divided by 20. Oops. 3 divided by 20 is 0.15, which is 15%. And then I saw a couple of people write, well, 3/20ths, if I want my denominator to be a 100, because that's what a percentage is, multiply the top and bottom of this fraction by 5. So multiply by 5 over 5. 20 times 5 is 100. 3 times 5 is 15. So if you convert that to a fraction that has a denominator of 100, you get 15 out of 100, which is the definition of 15%. All right, so is that a reasonable restaurant tip? Matter of opinion? It's reasonable. It's within the realm of acceptability, right? All right, so calculate a reasonable tip for a meal that came to $56.80. So we have lots of strategies here. Anybody want to share how they do this? Yep. Oh, so you use like a calculator? You did 0.15 times 56.80 gets you 852, right? Okay, so that would be an exact 15% tip. What do you do when you're actually out? Well, everyone carries a cell phone now, but yeah, okay. Emma, what do you do? And then double it, yeah. Good. Yeah, that's really good. So there's two strategies, one for 20%, one for 15%. So if I want to do 20%, and let's say we want to do it in our heads, we would just move the decimal 1 to the left, and that gets you 10%, right? That's what happens when you do 10%. It just moves the decimal 1 to the left. So if you want 20%, you would double that. So you have 568, double it, and you get 10 plus 68 doubled is $1.36, so $11.36 would be exactly 20%, right? What I tend to do in a restaurant is round that just to make the math easier. I would say just round it to 60, take 10% and double it, $12. So you end up leaving a little bit of extra change, but it's nice and even. If you were my grandfather, he would have probably left $11.20 to make it come out to a nice even number. Okay, so then the 15% method, take 10%, right? 10% is easy. 5% would be half of 10%. So you take your 10%, 568, take half of it, and then add that to your 568. So half of 568 would be 250 plus 34 cents would be 284. So 15%, I would say, we'll take my 10% plus half of that, which is 284, and add them together. I suppose I could do that in my head, but I don't want to. If I was going to do it the easy way, I would say round that to 60. 10% is 6. Half of that is 3. Add them together and you get $9. So there's lots of little things you can do to calculate these things in your head. All right, so imagine that you're shopping for a new iPod. you have 3 options. Which one is the best? You can go to Optimal Buy, and it costs $3.99 plus 6.75% sales tax. Or you can go to Hamiltonian Circuits. You can tell it's a really old problem, right? It costs $415, but you have a 5% off coupon, but there's still 6.75% sales tax. And then you found an online merchant in Portland, Oregon that will sell you the iPod for $441, and that includes shipping, right? That includes a markup of 5% for shipping. But you have a friend in Portland who's planning to visit you anyway, and you could ask her to pick up the iPod and save you the shipping charge. So which is going to be your best deal here? Okay, let's discuss this together. Okay, so if we just go down to Hadley and go to Optimal Buy, right? The local Optimal Buy. We're going to pay $399, right? Plus sales tax. So it will be 0.0675 times $399. So you have to take that percent, change it to a decimal, and multiply by the price. Okay. If you have trouble changing that to a decimal, so the general rule is move the decimal 2 to the left. 2 to the left. And if that is difficult for you to remember how many and which way, just remember what percentage means, right? Percent means over 100. So 6.75% per cent means 100, right? So this is 6.75 per 100, which is 0.0675. So it's another way to convert it. All right, so now I have to multiply that times $3.99. That's the amount of my taxes. So it's going to be $3.99 plus $26.93, and I'm going to the nearest penny, which is what they generally do with sales tax. Add that to the $3.99, and we get $425.93. All right, so if we go to Hamiltonian Circuits, that went out of business like 6 or 7 years ago, right? We have a 5% off coupon. So you take the 5% off first. You pay sales tax on the actual price of the item that you're going to pay. So when there's a sale, you can take the percent off first. So I'm going to take my $415 and subtract 5% of it. 5% as a decimal is 0.05. So 0.05 times 415. So my discount is $20.75. I do have to do the sales tax. Yeah, I'll do that in a second. So the sale price is $394.25. And then I have to add the sales tax. So I have $394.25 plus 0.0675 of that price. So take times 0.0675. So my sales tax is going to be $26.61. Add that to $394.25, and you get $420.86. All right, so already Hamiltonian Circuits is a better deal, right? Questions about technology really get dated fast, right? An iPod for $400, that's kind of crazy, right? Okay, so here's another one. The most complicated option is an online merchant that will sell it for $441, which includes shipping, right? So $441 is the highest price of the 3 already, right? $425.93, $420.86, and then $441. It's the highest price. But if you can get it without shipping, if you can have somebody go pick it up, maybe it would be more comparable to these two. All right, so I need to figure out what the price is without shipping. So I had some original price. I don't know what it is. What do you do in math when you have something that you don't know what it is? What do you call it? X. So we're going to say let X dollars be the original price. Okay, now if you need to increase that price by 5% to account for shipping cost, how do you increase a number by 5%? Yeah, I could take 5/100ths of it. Yeah. So I would take my original price and add 5/100ths of it. And what should I get when I take my original price plus the shipping costs? I should get $441. That's what they told me in the problem. Including shipping, it's $441. And now I have an equation, an algebra equation. I'm trying to find out how much this iPod costs without shipping. No, it says $441 includes shipping. So I want to find the price before shipping. Does that make sense? It does include shipping, but I don't want it to. If your friend is going to pick it up for you, you won't have to pay shipping. So I'm trying to figure out how much this costs without shipping. All right, so I have this equation. What is 1x plus 0.05 x's? Close. This is, if you have one apple plus 0.05 apples. How many apples do I have? 1.05 apples. I called it apples to make it more obvious. Same thing. Okay. So, and this is a shortcut in how to increase a number by 5%. We talked about this in the exponential growth, right? If you want to increase a number by 20%, you could just take 20% and add it to the original number, or you could multiply by 1.2, right? If you want to increase a number by 5%, you can do this, take 5% of it and add it to the original, or you can just multiply by 1.05. 1, keep 100%, 5, add another 5%. And then we just divide by 1.05. So X, my original price, will be $441 divided by 1.05, $420. Yes. No. So, okay, it's a good question. It's a really good question. And I'm sure that it's probably the most common mistake that people make doing this problem. Okay, so if you take 5% of 441, or 95% of 441, whichever, take 5% away or keep 95%, I would do 0.95 times 441, and you'd get 418.95, right? So then we should check, though. Like, we should check that if we increase, if you think that this is the original price of the iPod with no shipping, we should be able to take 5% of that and add it back on and end up at 441, right? So if I do 418.95 and add 5% of 418.95, right, times 1.05 to increase that by 5%, it actually comes out to 439.90, not 441. So that can't be the original price of the iPod. And it's all about which number you took 5% of, right? 5% of the original price and 5% of 441 are going to be two different numbers. So, in case anybody's reading that later, that's the wrong side. All right, so which one? Which one's the best deal? C by 86 cents. Yeah, I know. I guess it depends on how much you like this friend. How much the friend likes you. Yeah, to save you 86 cents. Yep. Okay, so here are a couple of formulas for percent increase and decrease. You really don't need to memorize these. We just did percent increases and decreases without having these formulas. If you want to increase a quantity by X percent, right, I stands for the increased amount, Q stands for the original quantity, you're going to take 1 plus X over 100. So like if it was 10%, this would be 1 plus 0.1, right, times your original amount. So the 1 stands for keep 100% of what you had, and then the plus means increase by a certain percentage. And if you want to decrease by X percent, D stands for the decreased amount. Take 1, which represents 100%, and take away how much you want to decrease by. Right? So if you wanted to take away, decrease by 30%, that means that you get to keep 70%. So the 1 stands for 100%, take away the decrease amount, and leaves how much you get to keep. You can also use those same formulas to solve for X or Q. Right? Plug in this, if you know the decreased amount, you could solve for the other two variables. All right, so here's another example. On a particular day, the Dow Jones closed at 12,875, and on the next day, the Dow closes at 13,029.5. What is the percent increase? Right, so we can figure out how much it increased by, but that amount could be big or small depending on where you started, right? So I used the example before of a salary increase. If you make $10,000 a year and you get a $1,000 a year pay increase, that will make a big difference to you, right? That means, that you could, buy, it'll make a big difference in your buying power, right? But if you are like a millionaire or a billionaire and you get an extra $1,000 a year, like that's like nothing, right? It's like you don't even notice because you have so much money. So that's where a percentage increase comes in handy. You need to compare the amount increase to where you started, right? And it tells you, that gives you a measurement of how big or small that jump is relative to where you started. All right, so 12,875, we increased by some percentage and landed at 13,029.5. Okay, so let's let X be the percent increase. And we'll say that it's as a decimal. We'll change it to a percent at the end. So I'm going to take my 12,875, and I'm going to say I multiplied that by some number to increase it. We'll just call this 1 plus X. Let's just call it X. Make it simpler. All right, we multiplied that by some number, and we got 13,029.5. So how do you figure out what we multiplied 12,875 by to make 13,029.50? Divide. 12,000 times X, so to undo that, divide. And we get X is so 13,029.5 divided by 1.012. Okay. So that's what I multiplied 12,875 by. Let me write that over there. That's what I multiplied the first day's Dow by to get the second day's. All right, so we need to interpret this number, 1.012. So the 1 represents 100%. We kept 100% of what we had, right? So let's analyze 1.012. So the 1 is 100% of the previous day. So that means we have more than 100%, right? The 1 stands for 100% from the previous day. What is 0.012? That's how much we increased by. And as a percentage, what is that? 1.2%. 1.2%. If I wanted to write that as a fraction over 100, I would have to move the decimal 2 to the right. So this is a 1.2% increase, right? So I kept 100%, that's the 1, and then that represents a 1.2% increase in the Dow. So we increased by 1.2%. All right, so I want you to try the next one. Now, the third day, we have the Dow Jones closing at 12,508.32. What is the decrease from the previous day, from 13,029.5? What's the percent decrease? Okay, so let's do this together. I saw several different approaches, and I'm showing you some approaches. You might have learned this a different way, and it's totally okay to stick with what you know. I'm just trying to review a little bit so that everybody has a common starting place. Okay. So if you want to set this up the way I did in the previous one, you take your starting amount and you say, okay, what do I multiply this starting amount by? Right, so that's what the x is. What do I multiply that by to make 12,508.32? Can you turn that down, please? Okay, so that's what a percent increase or percent decrease is. You multiply by a number to make it bigger or to make it smaller. So if I divide by 13,029.5, let's see, I hate that this calculator always shuts off. Okay. 12,508.32 divided by 13,029.5, and I get 0.96. So that means, what does that x mean? 0.96 as a percent, change that to a percent, what is it? 96%, right? So that means that if I take 96% of one day's Dow, I get the next day's Dow. So if I only have 96% of what I started with, how much did I lose? 4%. So I have a 4% decrease. I lost 4% because I only kept 96%. So that's one way, is to just figure out what is the multiplier and then interpret that multiplier. Okay. If you want to use the formulas that I gave you, as I saw a bunch of you doing, right? We said decrease is your 1 minus x over 100 times your original quantity, right? So then plug in the stuff that you know. My decreased amount is 12,508.32. 1 minus x over 100. And then the original quantity was 13,029.5. And then I would want to solve this equation for x. So these two methods are equivalent, right? It's just that instead of writing all this business down, right, I just put an x, right? And I solved for it in one step, and I got x and then interpreted it. This one, there'll be no interpretation needed. When you solve for the x, it will be the percent decrease. All right, so if I want to solve this thing for x, I would divide both sides by 13,029.5. and we're going to get 0.96 is equal to 1 minus x over 100, right? And then I'm going to solve for the x, right? So I might subtract 1 from both sides, and I get negative 0.04 equals negative x over 100. Multiply both sides by 100, and you get negative x equals negative 4, which means x is 4% decrease. Yeah, me too. It cuts down on the algebra. There's more common sense, less algebra in this first way that I did it.
I didn't use the X, I just put the 12.
You like this way better?
I don't like it better, but
But you don't like
when
the...
you give me that formula, I'm like, it's
Oh, yeah.
I just did the 12 by the way, 32.
Mm-hmm.
Divided by 50, 96. This is 1 minus 50%.
Mm-hmm. Yep, exactly. Without using x, you just divided the two. Yeah, that's an okay approach too. That's what you did. You said, Dwight, right? Yeah. Another thing you can do, since we're talking about approaches, is we can say, well, percent change is amount of change compared to the original amount. So if you prefer words to formulas, you can use this one. The amount of change to compared to your original amount. So how much the Dow changed is a subtraction problem, right? So I would say, well, 13029.5 minus, what was the other number? 508.32. So the amount of change is 521.18, right? Compared to how much I started with, which is 13029.5. That was what I started with. So the amount of change compared to what I started with, 4% change. And then you have to interpret whether or not that's an increase or a decrease based on did the numbers go up or down, right? So that's another way to get percent increase and decrease. This is actually kind of my favorite way. I should write this formula in the notes next time. Okay, so percent decreases are often used incorrectly. If you read the paper and look at statistics, you will find this mistake made all the time. Sometimes it's on purpose. Sometimes it's just people don't know how to use percentages, right? But sometimes it's used on purpose in an effort to exaggerate or mislead. So here's an example. The police chief of Happyville reports that crime decreased by 200% in 1 year. Before you continue reading, you should be very skeptical, right? How much could something possibly decrease by? 100%. If it decreases by 100%, it is completely gone, right? You took all of it and threw it away. So if you decrease by 200%, we now have negative crime. I mean, are people like walking around doing random acts of kindness? I don't know. But this is how he came up with this number. He said, well, reported crimes decreased from 450 to 150. Why does the police chief think he can get away with saying a 200% decrease? And what is the real percent decrease? Okay, let's talk about what happened here. All right, so let's use two methods, 2 or 3 methods maybe. So I've shown you 3 methods for calculating a percent change. So the first one is to say, take what you start with, figure out what you multiply by to get the finishing amount, right? So if I had 450, what do I multiply by to make 150? No. Divide by 450, divide by 450, and x is 150 divided by 450 is 0.33. Okay, now we have to interpret this, right? 1/3 of 450 is 150. That's what this says, right? So that means of the crime that I had, a third of it is still left, which means I decreased by 2/3. So my percent decrease is 0.67, 67%. Yeah, it's just a rounding issue. Yeah. Okay, so that's method number 1. Yes, I would. Or 66, sure. Okay, another way is to use the formulas that I wrote on the beginning of the paper, right? We say the percent decrease is 1 minus x over 100 times your original quantity. So your decreased amount is 150. Your original quantity is 450. And we want to solve for x, which is the percent decrease. So there's no interpretation with this one. X is the percent decrease. In this one, x was a multiplier that you had to interpret to get the percent decrease. All right, so I'm going to do the same thing. 150 over 450 is 0.33. Repeating. And that's 1 minus x over 100. Subtract 1 from both sides, and you get negative 0.67 is negative x over 100. So I just took this 1 and did minus 1, minus 1. And then multiply both sides by 100, and you get negative 67 equals negative x. So x is 67%. That's my percent decrease. So that formula, the nice thing about it is that there is no interpretation, right? The x that you solve for is the answer. In this one, the algebra is easier, but you have to take that x and interpret it and figure out what the percent decrease is. And then in this last method, that I didn't write this formula on your packet, so you might want to add it, is that percent change, whether it's an increase or decrease, is always the amount of change divided by the original amount. Okay, so how much did I change by to go from 450 down to 150? How much was that change? 300. And I would divide by my original amount, which is 450. And you get 0.67, which is 67%. Yes. Sure. Yeah, you can call that delta change. Yeah. I rounded. It's 0.66666666. Yeah. Okay, so clearly in our 3 various methods of calculating percent decrease, we got a 67% decrease. Why on earth does this police chief think that he can say 200% decrease? Where is he getting that?
If he's doing integrals by 150. If every 150 equals 100%, that's mine.
In his mind, every 150 equals 100%. Why? Why is he equating 150 with 100%, Emma? Yeah. Yeah.
Only second it goes from 150 to 300, it's double.
150 to 300 is doubled. Yes. Every third, he's thinking every third is 100%. Right, but you can't, that doesn't make any sense. Right. So if you look at this formula, percent change equals amount of change compared to something, right? Compared to a baseline, which is also always your original amount. This police chief went 300 and he said, I'm going to compare this to the wrong baseline, whether he did it on purpose or not. He put the finishing amount down there, right? And got 2, which is 200%, right? If crime had grown from 150 to 450, that would be a 200% increase. You can grow by more than 100%, but you can't decrease by more than 100%. A 100% decrease means everything, all 100%, is gone now. All right, so an important part of being a smart shopper is understanding how markups and markdowns work. So I want you to discuss in your groups. Toy store buys a certain toy, and they mark up the price, and then they put it on sale, and then they put it on clearance. What's the percent profit or loss for the store on this toy? Okay, so we assume that the toy cost the store $100. Okay, so that means I'm just going to go through the markups and markdowns one at a time, because I'm going to assume that there isn't an easy way to do this problem, right? So an 80% markup, so up by 80%, right? So $100 increased by 80% takes me where? To $180. Right? All right, and then from here, from $180, they take 40% off. Okay, so from here, we do minus 40%. Actually, I'm going to put it down instead of a minus. Decrease 40%. So that means that you're keeping 60%, right? If you're taking 40% off, then they're actually charging you 60% of the original price. Quick way to do 10% is move the decimal one to the left and then multiply that by 6, because 10% times 6 is 60%. So 18 times 6 is 108. Right. I was going directly to the discounted price rather than calculating the discount and subtracting. So instead of doing 40% and subtracting, I just did 60%, and you get 108. Okay, and then we do another decrease when it goes on the clearance rack of 25%, which means that we get to pay only 75%, right, of the original price. If you take 25% off, you're going to be paying 75%. So if we do 75% of 108, we get 81. So that's your final price, $81. The store is losing money, right? They bought this toy for $100 and now they're selling it for 81. I don't know. So amount of change compared to original amount. We dropped from $100 to $81. That is a $19 change. Compared to the original price of the toy, which was $100. 19 over 100 is 19%. So this is a 19% loss, right? Because the price of the toy went down by 19%. All right, we've only got 5 minutes, and I really need to do this next part. So stop talking. Thank you. All right, a very important concept in the business world is the idea that money has a present value and a future value. If you invest P dollars today for a promise of getting F dollars in the future, you would expect F to be more than P. Otherwise, why would you do it, right? If I say, sure, you can have $100 of my money today, as long as you pay me back some certain amount in the future, that certain amount that I get back has to be more than 100, or it's not worth it to me to give that money, right? So if we are given the present value, how do we calculate the future value and vice versa? The most important part of this depends on the interest rate. Okay. So interest is the return the lender expects as a reward for the use of his or her money. So if I give the bank $100 of my money and say, pay me back in 3 years plus some interest, that interest is the reward I get for letting the bank use my $100 for 3 years. So the standard way to describe an interest rate is a yearly rate called an APR, an annual percentage rate. So simple interest is the simplest kind of interest. Only the original money invested or borrowed gets interest over time. So this is different from compound interest that we'll talk about next class. In compound interest, the principal generates some interest, and then the principal plus your interest generates more interest. It'll be clearer next class. Okay. So in simple interest, the future value of P dollars invested under simple interest at an APR of R% is given by the future value is equal to the present value times 1 plus RT. R is your interest rate as a decimal, and T is time. So one quick example. On the day you were born, your parents purchased a $1,000 savings bond that pays 5% annual simple interest. What's the value of the bond on your 18th birthday? Okay. So future interest, future value is equal to present value times 1 plus RT, and we plug in the stuff we know. Present value, $1,000. The day you were born, we'll call that the present. So this is $1,000. My interest rate as a decimal, 5% as a decimal is 0.05, times time, in this case 18 years, and then we calculate how much this is. And it should be more than 1,000, right? Otherwise, why would we invest this money? So the order of operations says do what's in parentheses first, and within the parentheses, we should do the multiplication before the addition. So I do 0.05 times 18, add 1, then I take all of that and multiply by 1,000. And I get $1,900. Okay. So this is the idea behind investing. You give the government, this is a bond, right? So you give the government $1,000 for the promise that when you take that money back 18 years later, they'll give you $1,900. They give you a 5% rate of return. Only on your $1,000 though. Every year you get 5% of $1,000. All right, so the value of the bond on any given birthday would be your future value is equal to 1,000 times 1 plus 0.05 T on your teeth birthday. All right, so that's good. That's enough. You should be able to do your homework. We just didn't get to this last example.